You ready for project scheduling? Yeah. I didn't mean that. I'm just trying to get you to realize this is all for editing. Editing. Is anybody watching these videos? You are? Danielle, you watching? Thank you. Project scheduling. Here, I remember. Hey, what are these numbers up here? Is this on video? Darn. We can't talk about that. I should have talked about before I started the video.
These numbers you pulled out of your head.
No, not out of my money. Thank you. Thank you. This one right here. I remember being in, I think I was in elementary school. And my friend of mine lived across the street, four doors down in a neighborhood. We were in a subdivision. And my friend, we used to compete on everything. We did the craziest thing. We would have this thing where we would race around the house, grab the basketball, whoever could make 3 shots in a row, run through the garage as fast as you can, dive into the pool, swim to the other side, get out, get up on the dive board. We would then have to do a back dive, go to the very bottom of the deep end, and grab as many golf balls as you can and come back up. And the winner would be based on speed, amount of golf balls. There was points for each one. And then we'd do all kinds of these crazy things. But one day, I came out of my house on the front porch, and I looked down the road, and he's bouncing the basketball. He's going like this. And I'm looking, and I'm staring. This is the first time I ever noticed that I can see the basketball hit the ground, but I don't hear it until the basketball gets back up to his hand. Does anybody know what I'm talking about? Yeah. Have you noticed this? And that's the first time I said to myself, what is going on? I see the basketball bounce, but I don't hear it until after it bounces. And that's when I realized light travels at 671,000 miles per hour, but sound only travels at 761 miles per hour. Do you realize that? I want to make sure everyone realizes that. Everything you're seeing, right now I see this, right now I see this. But what I see happened a millisecond before I see it. It had to travel to my eyes. It's just traveling so fast. I remember explaining this to my father before he died. He said, what do you mean it's not instantaneous? What are you talking about? It's instantaneous. He could not comprehend that light travels and that we're seeing reflection of light, and it takes time to get to it. When you look up in the sky and you see a star, no matter which star it is, the light you see is at least 4 years old. Does everybody realize that? Any star you're looking at, except for the sun, whatever light you're looking at has been traveling for at least 4 years before you can see it. At 671,000 miles per hour. And sound's only going 760. This is 11. You want to know what this is? This is how many zeros still exist in this class because you're not taking it serious enough. That's what that is. And I posted on Blackboard, this is a perfect time to turn your zeros into scores, and not one of you turned anything in. Not one out of 11 zeros, not one got turned in. That's what that number is. All right? How crazy. Do you realize this class is set up that nobody should have a zero? I've set it up to where you have to work to fail this class, and that's how you do it. Those 11 zeros are what's going to head you towards not passing this class. That's how this class is designed. And in a job, those zeros would lead to you losing your job. And you'll learn what unemployment is all about. And I suggest don't have taxes with help. You're going to need every penny. All right, you ready? That's what those numbers are. Here we go. Project scheduling. We're going to learn 2 of them today. When there's known activity times, which is rare, but it happens. And here is much more common. Uncertain activity times. This is much more common. I'm going to talk about known activity times. I've actually experienced project scheduling with known activity times. And in my case, it was the different buildings I was involved in when I was in upper management. Down in Detroit, I was participated significantly in the building of a 125,000 square foot museum, the Museum of African American History, down behind the Detroit Science Center, just around the corner from the Detroit Institute of Arts. This was a major project, and what I loved about it is the general contractor, we subcontract the general contractor, and then we're involved. There was 2 of us managing the museum. The executive director was in charge of all the art side, the exhibits, our art school, and all that, and I'm in charge of the whole, everything else. The security, the restaurant, the gift shop, the accounting department, human resources, payroll, and everything else, maintenance, everything other than art was my job. And we had projects, and that new museum we were building was a major project. What's great about construction projects is, anybody ever worked in construction, they all use project scheduling. And they've been through so many different construction projects, they know exactly how much time it's going to take to put the wire in. They know exactly how much time it's going to take to do all the drywall for 125,000 square feet. They know how much time it's going to take to do all the flooring, marble, tile, laminate, whatever. They know exactly because they've done so many buildings. And so it makes putting everything together to know what day this subcontractor has to start, what day this subcontractor has to start, makes it very easy with the known activity times. In real life, I've been on projects where you have meeting after meeting and nobody can agree on how much time it will take. And so you come up with, like, it could go this fast, it could take this long, but it will most likely take this long. And you almost always come up with 3 times. We call it the pessimistic, optimistic, ooh, it may only take 2 days. You know, pessimistic, 4 days, but we think it will take 3 days. And that's, you know, the center, the most likely time. That's how these work. The hardest part about these is gathering that information. And then, hang on. I don't want anybody to take notes on this. I'm going to demo something. Once you then, what is going on? Is this going to shut down there? I don't know. All right. The hardest part of project scheduling is coming up with all these activities. And trust me, you're looking at micro. When we were constructing that museum, I mean, this was pages of activities, pages. Here's the hard part also, unless you've experienced whatever the project is you're on. You have to figure out which one of these activities are going to be finishing and have to be finished before this activity starts. For example, whatever activity D is in this project, A, B, and C have to be all completed, all 3 of them, before this can start. This is called immediate predecessors. This proceeds directly to this project because it has to be done. And it may have to be done for this one, this one, this one, but it's immediately before this activity. And this activity, D, has to be done as well as C. I don't even know why C is there because it has to be done before D. Anyway, they have to be done before E can get started. And A has to be done before F can get started. Now, in this example, if A gets done before B and C, F can get started. It doesn't have to wait for B or C. It doesn't have to wait for D. It's immediately before A. And F could get the subcontractor could get going on that at the same time that maybe some of these other activities are going, B and C. This is how it works. I'm going to give you a lot of insight. We're going to see this twice. I'm going to show you the first time how this works. On a test. I'm going to take it there. You don't have to put together the schedule. I'm going to say, here's the activities, here's the immediate predecessors. But you might have to put together a network and figure out, the question's going to say, what's the expected time this project's going to take to be done? Here's the amount of time, and we have known activity times. You don't have ranges there, no. But how much time will it take for the whole project to be done? So, I'm just going to get this started so you can see. When you put this together, you always got to start with, oh, am I going to be able to see both at the same time, right? Am I? Yeah, all right. You got to say, you got to start with a start. So, hang on a minute. Man, is it on? Okay. You can't see it both. Darn. There was A, B, and C with nothing before it, right? No, nothing preceded it. Go back and forth. Nothing preceded it, right? So, that means activity A, B, C are both coming directly out of the start. All right? I don't want this to take too long. I'm going fast. How much time? Has anybody got, 312? Yeah. A is going to take 3 periods of time, days or hours, whatever, weeks. And B is going to take 1, and C is 2. Yeah. All right, that looks like that. Yeah, let me get my boxes in here. All right. Now, look at what's next. And it looks like, well, we do D as long as A, B, and C are behind it, because they have to precede it. So, and they're all three preceding it. So I'm going to put D right, I'm just going to throw D right here. And it has to be preceded by all three of these, so I'm just going to put arrows, all three to that. See what I'm doing here? Okay? This is how I'm going to figure out the activity time. And D is supposed to take 4 units of time. I'm just going to go a little bit farther. E is preceded by C and D. Well, D has to precede it, so E has to be in front of D. And the other one's C. So I'm going to put E in front of D. And what was the other one behind E? C. Okay, so down here. So one's in front, E, and E is supposed to take 5 minutes, 5 units of time. And D and C are before it. Extend it out. And it looks like that. All right, hang on, let me get my boxes. You see what I'm doing here? This matches A, B, and C are preceding D. E is being preceded by C and D. F is preceded by A. G is preceded by F and D. See how this all works out to that chart? Now, I'm going to do what's called a forward pass. This is how you find the amount of expected time this project will take. And here's the logic behind it. You're going to see this twice, so I know you're going to want to write notes, attempt to write notes right now, but I just want you to watch this and absorb it, and we're going to see another one where I want you to take notes on the logic behind this. You ready? A is coming from the start. I didn't write the times on here. 3, let's be 1, 2. Okay, A is coming from the start, and so it's one of the first activities that are going to begin, and so it starts at 0. And it's going to take 3 units of time, correct? So it's going to finish, let's call these days. I don't know if it is or not, let's call it days. On day 3, A is expected to be finished. B, coming from the beginning. So it will start at the very start, takes 1 day, done on day 1. 2, coming to the beginning, 2 days. Now, let's do, D has 4, E has 5, and F has 3. D, you ready? Here it is. D takes 4 days. When, E, S, E, F, you're going to see this again, L, S, L, F. The left-hand corner is the earliest start for an activity. The right-hand corner is the earliest finish. The bottom left is the latest start. The bottom right is the latest finish. Now, you want to see the rest of that yet? D, this box is what we're talking about right now, which is the earliest start. But D cannot start until all of its preceding activities are finished that are directly behind it. Follow the arrows. A, B, and C all have to be finished. So on what day, and it can start on the same day that an activity finishes, because one activity may finish in the middle of the day. What day will D start on, the earliest it can start? Day 3. And what you did just now is you looked at what the earliest finish would be for the 3 activities that preceded. And you said, well, it can't start on day 1 because this and this wouldn't be finished. It can't start on day 2 because that won't be finished. Day 3. And the logic here is whatever the largest amount of time it takes for any of the preceding activities, that's the soonest the next activity can start. Let's go to E, preceded by both D and C. Oh wait, D, when is it going to finish? I forgot.
7.
That's right, 3 plus 4 makes 7 on day 7. E is preceded by both D and C, but they both must be finished before E starts. What day will E start on?
7.
You got it, 7. Finish on early as what day? 12. Add 5 to it, you get to 12. Go to F. F is preceded by A, which is only 1 activity. As soon as A is finished, F can get started, day 3. And it will finish as early as day 6. You got it. We're going to G. G is preceded by, we don't even know the time on G. 6 and H is 4. Okay. We're going to G. G is preceded by F and D. G can start as early as what? 7. That's right, the bigger of the 2. One is at 6, one's at 7. It's got to be the larger number going forward. Add 6 to it, finishes on day 13. We're looking at H. H is preceded by E. E finishes on what day? So it starts on 12, add 4, 16. This project isn't finished till every activity is finished. The project time is expected to take how long?
16.
There you go. That's how you find the project time. That's called a forward pass. Here's what everybody forgets. When you get to an activity that's preceded by more than one activity, it's whichever the latest, the bigger number is. The bigger number, how's that? The latest, earliest finish is the one that then tells you when the preceding activity, or the after activity can start. Everybody got that logic down? Now, here's where I start to lose people. We're doing a backward pass. This backward pass is done to identify the critical activities, which will make sense when we start getting into this. When I do a backwards pass, I got to follow the arrows from the finish to whichever activities are going directly to the finish, because they didn't precede any other activity. So I see that both G and H are coming out of the finish. You agree? Yeah. And the project is going to finish on day 16. So if we were going backwards, either one of those activities could finish on day 16, because nothing comes after it but the finish. So I'm going to put the latest finish of 16 here and 16 there. Now subtract the amount of time that that activity could take to figure out the latest start. Let's start with H. 16 minus 4 is 12, correct? Yes. Now, when you see that the earliest start and the latest start is the same, and the earliest finish and the latest finish is the same, you just found the critical activity. There's no wiggle room for activity H. Activity H must be there on day 12. They must. If they're not there on day 12, the whole project is delayed, which I'm going to explain, costs money. Lots of money. Let me keep going. G, 16, it takes 6 days. So 16 minus 6 is 10. Critical activity, yes or no? No. That's right. The difference from either the starts or the finishes is called the slack. How much slack is there? No, the difference between either the starts or the finishes? 3. 10 minus 7 or 16 minus 3. Earliest start, latest start. And what this is telling you is, hey G, now this, I'm going to get more into my experiences with non-critical activities in a minute, but this is saying that there's 3 days that that activity has some grace period. Even though they said they're going to be there on day 7, if they don't show up, we're okay, because they could be as late as day 10. My advice, you never tell a subcontractor that they could be there as late as day 10. Never, ever. Because they won't show up till day 10. Period. So you schedule for day 7 and you hope they make it, and then you get on them and you say, you got to be here tomorrow, which really you have till day 10. And if they don't come on day 10, now the whole project's delayed and it's costing a ton of money. And let's keep going. Go to F. Tell me what number would be the latest finish for F? 10. Subtract 3, 7. Is this a critical activity? How much? What was the slack back here? This is 3. What was the slack back here? What's the slack? Got that? 4-day slack. We would love for them to start on day 3, keep us on schedule, but they really don't have to start until day 7. Again, we would never tell them that. E. E, coming from H, right? So what number would be right there? 12. That's right, because H's latest start is 12, so this has to be done by 12. Minus 5 is 7. What did we just identify? That's critical activity. There's no slack there, no room. You have to go and get them out of bed and drive them if you have to. There's no possibility of them not showing up. They have to be there on day 7. They couldn't be any more important. D. After D, we got 2 activities on the right side of D. We got this one. Look at the numbers. This one. Now here we go. We're going backwards. We're going backwards. What number do you think should be right there? And get ready to tell me why. Hang on, I heard a 7 and a 6. What? Wait, not 6. I heard a 7 and what? 10 and 7. The latest start here is a 7. The latest starts there at 10. Now, you got to think about this. For these to start, this has to be finished. It's always on the backwards, the opposite of forward is the smallest number if you have multiple activities. So this one will be a 7. Because if it goes past 7, it delays the whole project. This critical activity could not start. And so this 10 means nothing. It has to be 7. Subtract 4, we got 3. We just identified a critical activity. We got all 3 of these coming from this. This A has F after it, has D after it. What number goes there, the 7 or the 3? That's right, the smaller number. This is where, when we get to this again, you're going to write notes. Forward pass, if you have a decision to make, the largest number. Backwards pass, a decision to make, smallest number. That's how I remember it. Subtract 3, we got a 0. What did we just find? B has just D after it, and the latest start is a 3. Subtract 1, that makes a 2. Tell me how much slack we got on B? 2 slack. A G only has both D and E, so we got a 3 and a 7. What goes here? 3. 3. Subtract 2, we got a 1. Slack on this one? 1. There you go. Identify the critical path. From the start to the finish, follow the critical activities. They're always going to be touching. A, D, E, H. That's called the critical path. You would write it like an A dash, D dash, E dash, H. All right? All right, you're ready. I think you're ready. Here we go. There's a question. It's going to be answered on this anyway.
So it has to be a dash, not an arrow.
I'll take arrow, dash. I don't care. A dot. It's just identify the critical path. I just want to see you have the right letters.
Okay.
All right, I'm just telling you how it's written. All right, here we go. Here's our example. This is where you're going to want to take notes, but it's going to make a lot more sense. This float company has to build a float. They took all the activities to build these floats and broke them down into individual activities. They know exactly how much time each one of these activities is going to take. What's going on? Are we get out of class? What's going on? What's this process? We're just checking. It looks like people pick it up. Here are the activities, right? Here's the immediate predecessors. Here's the activity times and days, right? Hang on. Where am I? Where's my piece of paper? And when you network it, it looks just like that. Are you ready? Again. Let's go. Let's do this. This is the same thing you just saw on my slide. This is the same thing, same project, amount of days. Let's see if we can get the time it takes to do this project. Let's start with A. Earliest start. I heard it. Earliest finish. 3. 0 plus 3. B is before A, so its earliest start would be day 3. Earliest finish would be day 6. C is after A. Its earliest start would be, add 2, we get 5. Let's go to D. D has just B before it. B finishes on day 6. So it can start on day, no, 6. 6, I said it wrong, but I meant this right here. Because this is before it, it's going to, earliest finish is 6, so this can't start till day 6. Add 3, earliest finish is a 9. Now let's go to E, way down here. It only has C before it. C's finishing at 5. Add 7, what do you get? 12. Let's go to F. We have B and C before it. So F can't start till they're both finished, which is day 6. Very good. Add 3. Now we're going to G. G has D and E before it. So let me look at both D and E. G can't start till day 12. Very good. Add 6. That's 18. Look at H. Only C's before, so it can start as early as 5, because the C's the only one before it. Add 2, you get 7. This project will take how many days? 18. That's right. Even though both H, F, and G all don't precede any activities, so you can take them right to the finish, 18 is the biggest number. All of them have to be done before the project's done, so the project expected time is 18 units of time, whatever it may be. That went fast. That was good. That's the same thing, right? Whoops, hang on. This is it right here. So we did a forward pass. You had 18, a 9, and a 7 all coming to the end here. All right?
Can you go back to your thing? I think it might be easier to see.
Ready?
Just because it's closer up. Yes.
All right. Well, let's do a backwards pass while we have this up here. Why not? Backwards pass. What do we do on 10? Backwards pass. Here we go. Here's the finish at 18. There's 3 activities coming from the finish that go directly to the finish. I got to use the expected time of the project for the latest time each of these activities could finish. They don't have to be finished before the 18th day. That's right, number 18. So I got 18 here, 18 here, 18 there. All 3 of those arrows that come from the end can finish as late as 18. Subtract 6, I got 12. What's G? Critical activity. There it is. F, 18 minus 3 takes us to 15. We got some slack there. 18 minus 2 is 16. Look at the slack there. How much slack on H? 11. Right? You can just subtract the starts or subtract the finishes. You're going to get 11 either way. This is where we're taking notes. Backwards pass, when we get to one that has more than one, you've got to remember which number to use. So this is where you would write. We're on E. E has only G after it. G's latest start is a 12. So E 12 minus 7 makes 5. E is a critical path. Here we go, D. Nope, D only has G after it. So it's also a 12. Minus 3 makes 9. It's not critical. No, it has slope of 3. Now we're going to C. Finally, here we go. Jonathan, you're going to answer this, and then I'll answer your question. C, you ready? C has F and E after it. You see their latest starts. What is going to be the latest finish for C? Who just said that to him?
I didn't even hear, honestly.
Okay, go ahead. What number's here? Oh, stop. This is acting.
5.
Okay, thanks. No, that's being a word for you. There we go. 5 right here. Was that C or D?
C.
C. Subtract 2, 3. Now hit me with your question.
So is the top number ever bigger than the bottom number?
I don't think so. I don't think it ever is.
Okay.
I don't think so. Nah, it can't be.
'Cause
It's either the same or the bottom number either has to be the same or bigger, doesn't it?
Right.
Yeah, there's no way a late finish could be earlier than a beginning finish. So yeah, I guess never.
All right.
Let's do B. We got 2 activities after B, D and F. The latest start for B would either be a 9 or a 15. Which is it? 9. Subtract 3. We get 6. A has both B and C after it, so we got a 6 and a 3. What goes there? 3. Subtract 3. We get 0. I want to hear what the critical path is. A, C, E, G. There's the critical path. A second. Can you, if you're given something like this, let's go with something like this. Could you then tell me the project expected completion time? Could you identify the critical path? Because you now feel comfortable you can do a forward and a backwards pass and get the right numbers, correct? You will have a forward and backwards pass in your future. Just want to make sure. And you will be asked to identify the critical activities and what is the expected completion time in this project. Blah, 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 blah. Here's our backwards, wait, let me say something. Here's our backwards pass, critical activity, here, where the numbers, all right, let's keep going. Wait, almost forgot, hang on. All right, this is project scheduling. Module what? 7, thank you, Mike. PERT CPM is project scheduling right there. File, new. Somebody has that PowerPoint. This is no activity times, right? The one we just did. How many activities were there? 8 through what? 1, 2, 3, 4, 5, 6, 7, 8. Is that what you just said? 8. All right, did okay? Looks like this. There's going to be 8 letters there. Activity A is supposed to take how long? 3. Is it preceded? There can't be. So there we go. Now I'm going to activity B. How long is activity B supposed to take? Huh? 3, really? And is activity B preceded by another activity, which on the list here could only be A? Is it preceded by A?
Yes.
So you click on there and watch how A appears as immediate predecessor on this list. Let's go to one more here, or 2 more. C is supposed to take how long? 2. 2. Is it preceded by any other activity?
A.
So just click on A. So now you got C preceded by A, activity time 2. Let's go to D. How long is D supposed to take? 3, preceded by what activity? B and A. What are we on? We're at D. Well, have I got the wrong drawing here?
No, it's preceded by B.
It's preceded by B only. Are we looking at a different one? Oh. So there's B. Now look, I put C. Oh wait, look at that. Look at, I accidentally put A, B, and C, but it's only preceded by B. Here's how you correct it using the software. You ready? I'm going to get rid of, what is it preceded by? I'm going to get rid of the A by clicking right there, get rid of the C by clicking right there, and now just the B's there. So this is how you correct it. And then you get it all done, you entered all the numbers, all the predecessors, and it looks like this, right? Are you ready? I'm now going to hit solution solve. Here's how you read the output. What's the critical path? There's 2 places it's showing you. Right there it's showing you, and right here it's showing you the critical path. It's showing you, not in the same exact order we had it in, here's the earliest start and the earliest finish. This would be the top left and the top right if you're looking at the output on those cells if we did a forward pass. Bottom left, bottom right, if you're comparing it to the cells, the 4 blocks in each one of those. What's the project completion expected time to take? Right there, it says it here, and the latest finish. You look down the latest finishes here. All right? That's how you use the output. The output's posted on Blackboard. If you want to use the software, I mean, you can, but if this were a quiz, you're going to be given the output just like this and asked, what's the project completion time? What's the critical path? You know, what's the, how much slope? Even the slack's given to you. The slack's even give it to you right there. Okay, here we go. How much time we got? 12 minutes. So I'm going to introduce you to, this is project scheduling with uncertain activity time. See, Austin? All right, with uncertain. And the hardest part of this is coming up with this. In my day, we didn't have video conferencing. It was meeting after meeting after meeting, and you're over meeting. Just time and time and time. Debates. How much time should this activity take? Oh, it's probably going to take 6 hours. No, it could take 8. No, 4. If we get lucky, we'll go 4. Oh, but you know, we run into something that could take 8. Let's go with 6. This is how it goes. You should have an optimistic, a pessimistic, and a most likely number. Now, what you do from here is you got to convert all of these numbers for each one of the activities to one number so that it ends up looking just like this. We got to do some math, and then once we get it to this, everything's the same as project scheduling with no activity. The forward pass, the backwards pass, it's just getting it to this by doing the math to turn all those activity times into one number. Here's the formula. Right there. The most likely time is the big deal. We pretend there's 6 numbers in front of us, but 4 of them are the most likely time. We're putting all weight on the most likely time. We're allowing the optimistic and pessimistic times to be involved, added to it, 1 each. But most of that weight is on that most likely. Then we divide by 6 numbers there. And that weighted average is what we're going to use as the activity time for each of those activities with that formula. Once you convert every one of these numbers to one number, 4 times 6 plus 8 plus 4 divided by 6. 4 times 4.5 plus 5 plus 1 divided by 6. Let's do this one. 3 times 4 plus 3 plus 3 divided by 6. What's the activity time for C? Wait a minute, not all at once. Let's do this again. The most likely time is 3. You multiply that times 4. You add 3, you add another 3, you divide by 6. What do you get? 3. The activity time for this one is easy because this is one where in the meeting we all agreed that we know this is going to take 3 hours. And so since you're doing with a bunch of activities that you're uncertain about, to put one that you are certain about, you put the exact same time for all 3 across, and that way you'll end up using 3 for that one. See how this works? Once you turn these all into single number, you do your forward pass and backwards pass, just like known activities. Now, what are we doing on time? You ready? I just want to make sure I'm not going to freak you out. Once we do our forward pass and backwards pass, because these are activities with uncertain activity time, they have variance. And with variance, we need to apply some statistics so we can see what the probability is that this project will truly get done in that amount of time. When you have uncertain activity times, what you just did all this math for is to have a target that you will most likely get this project done. But it won't be done in that amount of time. There's just too much variance involved with these activity times. Whoops, did I pass it? There's just too much variance involved. And it's that variance that will cause things to either go faster or slower or delays or whatever happens. But what we used to always do is say, let's figure out how much time will allow us to be with a 90% chance that that project will be done in that amount of time. And the reason this is so important is because when you're doing a project that you're not certain about the activity times, as the business person, accounting majors, this is hugely important because you're the one negotiating with the bank for what's called a bridge loan. A bridge loan on construction projects is where the bank says, yeah, we'll lend you $10 million, but and we know it's going to be expensive for you. This is why a project has to be done in time. I want to make sure you hear this. Here's how a bridge loan in real life, this isn't in your book, this is my experience. A bridge loan, the bank says, here is 1/3 of the $10 million. While this is being built, we're allowing you to only have to make interest payments on the $10 million. 10 million times, back then it was like 6%, divided by 12. Each month I had to make a payment on just the interest portion of that 10 million. Meanwhile, construction starts, money's going out the door. 10 million gets spent before you even realize it. You meet with the bank. Phase 2. They transfer another 10 million into your account, or if it's a 30 million, they do it in thirds. You now have more money, but the deal's the same. Your payment is now significantly higher because you got to pay interest payments on 20 million while the project's being constructed instead of only 10 million. You're not making a payment on principal yet. I want to make sure you guys realize this. So you planned for this, so you got cash flow, no problem. But you get the third one, the third payment. The project's going. You're paying just interest. But you've already agreed when you negotiated this bridge loan that you are going to start making principal and interest payments on blankety blank date, all based on this schedule. And if you miss that date, that is your bad luck. You still have to make the principal and the interest payment. And if this project is not generating revenue, your cash will be gone so fast that you will go out of business because your employees won't get paid on payroll. And if they don't get paid, they walk. And if you're not making whatever it is that this business does, your business goes down fast. It's the biggest mistake businesses make, is not planning ahead. And that's what this does. It gets you to where you have I always say, let's get a 90% chance that we know this project will be done. That gives me only a 10% chance of possibly, and with only a 10% chance, I've had enough cash to get us through maybe 1 month or 2 months. But if we're so far off on when we thought this project was going to be done, I got to we're going to have to get some credit cards and start doing something because we'll run out of cash. Cash flow is what accounting's all about. And that's the worst thing you can experience is getting this close to running out of cash, not knowing where you're going to get more money because no one wants to lend you more money when you just borrowed $30 million that you're about to not be able to make your first principal payment or your second one. That's why this is here. So where we're heading is right here, where you are going to say, where's the critical path? I'm going to show you on Thursday how to calculate the variances for the critical path. Once you have the variances for the critical path, you square root it to get the standard deviation for this project. Once you have the standard deviation for the project, you say, okay, this project is expected to take 24 hours. What's the probability it will take 23 hours or less? If it's supposed to take 24, what's the probability it will take 23? It's the expected time. I gotta make sure I do this. I'm sorry. What is the expected time? I may be saying that backwards. 23. It's the one you're asking about. Hey, this is supposed to take 23 days. let's work with the bank on 24 days. Let's see where that puts our probability. 24 is what we want to say, you know, what's the probability of getting it done in 24? Well, we just calculate this project's gonna take 23 days. 24 minus 23 divided by the project standard deviation gets you Z. You go to the front or back of your book, I think, where the Z chart is. You look up the Z chart, and it will say there's a 76% chance of this project getting done in 24 days when it's expected to get done in 23. That's not good enough. That is too much risk for me when I'm managing cash, millions of dollars, that I know are gonna head out the door if we don't get it done within 24 days. So let's do it again for 25 days. 25 minus 23 divided by the project standard deviation gets you your Z. You look up your Z. And when this gets to 90, that's the number I'm going to use to plan everything out with the bank I'm developing that relationship with about to get the $30 million loan. That's where we'll leave off. We'll set up.